Picture this. It's 1982, and inside a cramped Mexico City garage, a Beetle engine strapped to a homemade dyno doesn't look like any Beetle engine you've ever seen. 4 camshafts where there should be 1, cooling fins machined into alien patterns, spacecraft-looking components everywhere. The operator hits the throttle, and the dyno reads 207 horsepower from an air-cooled Beetle engine. Volkswagen's engineers in Wolfsburg would claim this was impossible. They were wrong. The Beetle problem in Mexico. Let's rewind to understand why this matters. In the 1970s and 80s, Mexico had a complicated relationship with the Volkswagen Beetle. The government had basically made it the official car of the nation through import restrictions and tax incentives. If you wanted a new car in Mexico and didn't have serious money, you bought a Beetle, there was no choice. Mexico was assembling Beetles in Puebla, churning out hundreds of thousands of these things. By 1980, the Puebla plant was building more Beetles than Germany. Mexico had become Beetle Central. The problem was the engine. That air-cooled flat 4 that Americans found charming in their counterculture hippie mobiles was an absolute liability in Mexico. Think about it. Mexico City sits at 7,300 feet elevation. The air is thin. A stock Beetle engine, already wheezing with its 46 horsepower at sea level, lost about 15% of that power at altitude. We're talking about 39 horsepower trying to move a car through dense traffic, up mountain roads, carrying families of 5 because that's what people did. The stock 1600cc engine was pathetic. 0 to 60 in about 28 seconds at Mexico City's elevation. That's not acceleration, that's continental drift with a steering wheel. Passing on mountain highways was a religious experience. You'd pull into the left lane, floor it, and pray that the truck you were overtaking didn't speed up before you completed the maneuver sometime next week. But here's what's interesting. Mexicans didn't just accept this. The hot rodding culture in Mexico was insane, way more aggressive than anything happening in the States. Mexican mechanics were boring out engines, stroking them, welding on turbo manifolds made from scrap metal. There was an entire underground economy of Beetle performance parts, manufactured in small shops across the country. The problem was that everyone was working within the same basic limitations. The VW Flat 4 architecture had been designed in the 1930s. By the 70s, even with all the hop-up tricks known to man, you were looking at maybe 70 or 80 horsepower reliably. Maybe 90 if you didn't mind rebuilding the engine every few months. The cylinder heads were the bottleneck. Those stock heads with their tiny valves and terrible port design were like trying to breathe through a coffee stirrer. Hot rodders knew this. But making better heads required serious engineering knowledge and machining capabilities that most shade tree mechanics didn't have. This is where Raphael Pena comes in. And boy, did he have a different idea about what was possible. Enter Raphael Pena. Raphael Pena was not your typical Mexican mechanic. The guy had a degree in aerospace engineering from UNAM, Mexico's top university. He'd worked briefly for Aeromexico doing engine analysis. This was a man who understood thermodynamics, fluid dynamics, combustion theory. He could do math that would make most hot rodders' heads explode. But Pena had a problem. He was poor, or at least not rich enough to buy the European sports cars he dreamed about. In 1978, a Porsche 911 cost about what a nice house cost in Mexico City. Out of the question. Even a BMW was fantasy money. Like everyone else in Mexico, if Pena wanted a car, it was going to be a Beetle. Here's where his aerospace background kicked in. Pena looked at the Beetle engine the way an aerospace engineer looks at a jet turbine. Not as a car part, but as a thermodynamic device that converts chemical energy to mechanical work. And from that perspective, the stock Beetle engine was horrifyingly inefficient. The combustion chambers were all wrong. The valve timing was conservative to the point of criminal. The cooling was adequate but not optimized. The intake and exhaust ports looked like they'd been designed by someone who'd never heard of fluid dynamics. Which, to be fair, they probably were. Remember, Ferdinand Porsche designed this engine in the 1930s. Computers didn't exist. Fluid dynamics was still kind of black magic. Pena spent months analyzing every aspect of the VW Flat 4. He measured port flow with homemade equipment. He photographed combustion using high-speed cameras borrowed from the university. He built mathematical models of the engine's breathing characteristics. His friends thought he'd lost his mind. In 1979, Pena decided to build his own cylinder heads from scratch. not modify stock heads, design completely new ones using principles from aerospace engine design. His goal was simple: 200 horsepower from a naturally aspirated 1600cc Beetle engine at Mexico City altitude. People laughed at him. 200 horsepower from a Beetle engine meant you needed massive displacement, probably 2 liters or more, or serious forced induction. Building a high-revving screamer that made 200 horsepower naturally aspirated from 1600cc at altitude? Impossible. The laws of physics said so. VW's own racing department, with millions in funding, had never achieved anything close to that specific output on pump gas. Pena didn't care what was impossible. He had access to a machine shop through his university connections. He had aerospace engineering knowledge, and he had nothing to lose except time and whatever money he could scrape together. What he was about to create would make VW's engineering department look like amateurs. And the wildest part? The design looked like something from a science fiction movie. People would eventually call it the FUTURISTIC engine. Not because of marketing, but because when you first saw it, your brain couldn't quite process what it was looking at. The FUTURISTIC engine design. Here's where things get absolutely insane. Pena didn't just design better cylinder heads. He created something that looked like it belonged in a spaceship, not a Volkswagen. The core innovation was moving to a quad-cam design, 4 camshafts, on a Beetle engine. Let that sink in for a second. The stock Beetle had 1 camshaft in the crankcase, operating all 8 valves through long push rods. Pena said, "Forget all that. Put a camshaft directly above each bank of cylinders, operating the valves directly through bucket tappets. No push rods, no rocker arms, just cam lobe to valve." But here's the genius part. He didn't just add 1 cam per cylinder bank. He added 2, one for intake, one for exhaust. This gave him independent control over valve timing and lift. This was dual overhead cam technology, but doubled because of the flat 4 layout, hence quad cam. In 1979, DOHC was exotic technology. Ferrari had it, Lotus had it, Volkswagen definitely didn't have it. The fact that Pena was designing this in his apartment in Mexico City, while VW's engineers in Germany were still running push rods, tells you everything you need to know about corporate conservatism. The valve layout was radical. Instead of the stock 2-valve per cylinder setup, Pena went to 4 valves per cylinder, 16 valves total. This was absolutely unheard of for a Beetle. The intake valves were 32 millimeters. The exhaust valves were 28 millimeters. Wait, smaller than stock? Here's where aerospace thinking comes in. It's not about individual valve size. It's about total valve area and flow characteristics. 4 small valves give you more total area than 2 large valves, plus better combustion chamber geometry. The flame front can propagate more evenly, more complete combustion, higher efficiency, more power. The combustion chambers were hemispherical, perfect hemispheres, machined to within 10,000ths of an inch tolerance. The spark plug was centered at the top of the dome. This gave uniform flame travel in all directions. Textbook thermodynamic efficiency. But the really futuristic part was the cooling. Remember, this is an air-cooled engine. Pena couldn't use water jackets, so he designed the heads with an elaborate fin structure that looked like alien hieroglyphics. The fins weren't just slapped on randomly. They were mathematically optimized for airflow patterns, creating turbulence that maximized heat transfer. The heads were machined from solid aluminum billets. Not cast, machined. Each head took about 80 hours of machine time. The cost in 1979 was about 3 months of an average Mexican salary. Pena was burning through his savings like they were on fire. The intake system was another work of art. Individual throttle bodies for each cylinder, feeding through velocity stacks that looked like something from a Formula One car. The exhaust was engineering poetry. A 4-into-1 header with equal-length primary pipes, feeding into a collector that created a scavenging effect. At high RPM, the exhaust pulses would actually help pull intake charge into the cylinders, free power from fluid dynamics. Now here's the crazy part, the cam timing. Pena designed the cams with absolutely wild specs. 278 degrees of duration, with 13 millimeters of total lift. Stock Beetle cams had maybe 215 degrees and 8 millimeters of lift. This meant massive valve overlap. At low RPM, the engine ran terribly. It would barely idle. Below 3,000 RPM, it coughed and sputtered like it was dying. But above 5,000 RPM, magic happened. The engine would absolutely scream. The red line was 9,000 RPM. 9,000. Stock Beetles redlined at 4,500. Pena had doubled the usable rev range. This was possible because of the direct-acting cam setup with no push rods. Push rods flex at high RPM, causing valve float. Bucket tappets don't flex. The whole assembly, when complete, looked like nothing anyone had seen before. The finned heads gave it an organic, almost alien appearance. The 4 camshafts poking out the sides with their gear drives looked industrial and race-bred. The individual throttle bodies made it look like a racing engine, because it basically was. People who saw it for the first time would just stare. It didn't look like a Beetle engine. It looked like a prototype from some advanced racing program, except the program had a budget of basically zero and a staff of 1 aerospace engineer working nights in his garage. When automotive journalists eventually saw photos of the futuristic engine in the mid-80s, they couldn't believe it had been built in Mexico. The assumption was that Pena must have had help from VW's racing department, or Porsche, or someone. He didn't. He had a calculator, some textbooks, access to a machine shop, and apparently unlimited stubbornness. The question was, would it actually work? Could this science fiction engine deliver the 200 horsepower Pena claimed? Or was it just an elaborate exercise in over-engineering that would grenade itself the first time someone hit the throttle? Building the impossible in a garage. The construction process was a nightmare. Pena wasn't just building a modified engine. He was manufacturing a completely new engine design from scratch, in a country where getting proper materials was a major challenge. The aluminum billets for the heads had to be imported from the United States. This meant paperwork, customs delays, and bribes. Mexican customs officials in 1980 couldn't comprehend why someone needed high-grade aerospace aluminum. They thought Pena was smuggling something. He ended up paying triple the actual cost just to get the materials through the border. The machine shop time was traded. Pena would do engineering consultations for the shop owner's other projects in exchange for after-hours access to the mills and lathes. He'd work his day job, then show up at the machine shop at 8 p.m. and work until 3 a.m., grabbing a few hours of sleep before doing it all again. The precision required was insane. The valve guides needed to be held to tolerances of 5/10,000ths of an inch. One mistake, one moment of inattention, and 80 hours of machining work became expensive scrap aluminum. The camshafts themselves were a particular problem. Pena couldn't just buy performance cams because they didn't exist for his design. He had to have them custom ground. He found a cam grinder in California who thought the specifications were a joke. The guy actually called Pena to confirm. You want what kind of duration? At what lift? For a Beetle? This was followed by laughter. Pena sent half his savings to California and waited 6 weeks. When the cams arrived, they were works of art, perfectly ground, hardened, polished. They cost more than his entire car had cost new. The first complete engine took 9 months to build, 9 months of nights and weekends. Pena's wife thought he'd gone insane. His friends stopped calling because they knew where he'd be, at the machine shop. Always at the machine shop. When the engine was finally assembled, Pena spent a week just staring at it. It was beautiful in a strange, mechanical way. The polished aluminum, the gleaming camshafts, the individual throttle bodies, it looked fast sitting still. The first startup was terrifying. Pena had built a test stand in his garage with crude instrumentation, just basic gauges for oil pressure and temperature. His hands were shaking as he hit the starter button. The engine turned over. It coughed, sputtered. Black smoke poured from the exhaust. Pena's heart sank. Had he made some fundamental error? 9 months of work, his entire savings, all for nothing? Then the engine caught. The sputtering smoothed out. The smoke cleared, and holy hell, the sound. It didn't sound like a Beetle. It sounded like a miniature racing engine, a high-pitched mechanical scream that set off car alarms 3 blocks away. The cam timing was so aggressive that the engine wouldn't idle below 2,000 RPM, but above that, it sounded purposeful, mean, like it wanted to destroy things. Now came the real test. The dyno. The dyno numbers that shocked everyone. Pena's friend owned a motorcycle shop with a dynamometer setup. Not a sophisticated engine dyno, but a wheel dyno designed for testing motorcycles. Pena explained what he was trying to do. His friend laughed. "Bring your science project over. We'll see what it does." The test happened on a Saturday morning in October 1982. Pena had installed the futuristic engine in his 1973 Beetle. The car looked completely stock from the outside, except for slightly wider tires. Under the deck lid was what looked like a rejected prop from Star Trek. They strapped the Beetle to the dyno. The plan was simple: run the engine up through the power band, measure rear wheel horsepower, estimate engine output accounting for drivetrain losses. Pena was hoping for maybe 160 horsepower at the wheels, which would suggest about 190 at the crank. The first pull was conservative. Pena took it to 7,000 RPM, well below the engine's 9,000 RPM capability. The dyno readout showed 112 horsepower at the wheels. Everyone went quiet. That was already double what a stock Beetle made. From a conservative pull, the second pull went to 8,000 RPM, 153 horsepower at the wheels. People started gathering around. Word had spread. Other shop customers were wandering over to see what was making that unholy noise. The third pull was the one that changed everything. Pena took it to redline, 9,000 RPM. The engine note was a continuous scream, like a fighter jet spooling up. The dyno rollers were a blur. The graph on the dyno screen was climbing, climbing, climbing. Peak power hit at 8,700 RPM, 172 horsepower at the wheels. Accounting for 15% drivetrain loss, that was approximately 207 horsepower at the crank. From 1,600 cc, naturally aspirated, on pump gas. At 7,300 feet elevation, the specific output was 129 horsepower per liter in 1982. For context, Ferrari's Flat 12 in the Berlinetta Boxer made about 100 horsepower per liter. Porsche's naturally aspirated Flat 6 in the 911 SC made about 85 horsepower per liter. This Mexican engineer, working in a garage, had exceeded Ferrari's specific output using an architecture based on a Hitler-era design. Let that sink in. The dyno sheet printout became legendary in Mexico City's hot rodding community. People photocopied it, passed it around. Nobody believed it at first. It had to be a mistake. The dyno must be reading wrong. There's no way. Pena drove the car home with a huge grin on his face. The next day, he started getting phone calls. People wanted to see the engine. Other engineers wanted to know how he'd done it. A few people accused him of fraud. One caller insisted he must have hidden a turbocharger somewhere. So Pena did something smart. He invited everyone to a parking lot the following weekend. "Bring your fast cars," he said. "Let's race." The street race that followed entered automotive folklore. Against a highly modified 2-liter Beetle that was known as the fastest in Mexico City, Pena's car won by 4 car lengths. Against a turbocharged VW that supposedly made 180 horsepower, Pena won by 3 lengths. Against a small block Chevrolet engine-swapped Beetle, Pena won by 2 lengths. The car was traction limited. The stock Beetle chassis couldn't put down all that power effectively. But even with the tires spinning through first and second gear, it was faster than everything else. Raphael Pena had proved his point. The futuristic engine worked, and it worked better than anything else in Mexico. The question was, what would Volkswagen think about this? VW's reaction and industry panic. Word reached Volkswagen de Mexico pretty quickly. The Puebla plant managers heard rumors about some crazy engineer in Mexico City who'd built a 200 horsepower Beetle engine. They dismissed it as typical hot rodder exaggeration. Then they saw the dyno sheets. VW de Mexico sent 3 engineers to inspect Pena's engine in early 1983. They showed up at his garage unannounced. Pena, understanding the situation, was perfectly happy to show them everything. He wasn't trying to keep secrets. He was actually hoping VW might be interested in manufacturing the design. The VW engineers spent 4 hours examining the engine. They measured everything, took photographs, asked hundreds of questions. Their conclusion was documented in an internal memo that was later leaked. The memo stated, and I'm translating from Spanish, "The design is technically sound and represents a significant advancement over existing air-cooled engine architecture. Manufacturing feasibility is questionable. Recommend observation but no action at this time." Translation: Holy crap, this works, but we can't acknowledge that some random Mexican engineer outsmarted our entire R&D department, so let's pretend it doesn't exist. VW Germany heard about it next. They requested all documentation from the Mexico visit. Then, they sent their own engineer from Wolfsburg to investigate. This engineer, whose name was never disclosed, reportedly told Pena that his design incorporated concepts VW was researching for future applications, which was corporate speak for, "You figured out things we're still working on." But here's where it gets interesting. VW made Pena an offer. They would buy his design outright for what in today's money would be about $50,000. They would also offer him a position at VW de Mexico as a development engineer. In exchange, Pena would surrender all rights to the futuresque design, never publicly discuss it, and allow VW to patent the innovations under their name. Pena said no. The money was tempting, the job was tempting, but giving VW credit for his work, letting them bury it like they'd buried other innovations that threatened their existing product line, not happening. VW's response was predictable. They threatened patent litigation, claiming Pena's design infringed on their existing intellectual property. This was obviously nonsense. The Futuresque shared nothing with VW's designs except the basic layout of a flat 4. But legal threats don't have to be valid to be scary. Pena, being smarter than VW gave him credit for, had already filed for Mexican patents on all his major innovations. The quad-cam setup, the cooling fin geometry, the valve train configuration, all protected. VW would have to prove prior art, which they couldn't, because they'd never developed anything like this. The legal threats quietly disappeared. But VW made sure that parts suppliers, machine shops, anyone in Mexico who might help Pena manufacture the engine, understood that helping him would cost them VW's business. And since VW was the largest automotive manufacturer in Mexico, that was an effective blockade. Other manufacturers took notice, though. Porsche reportedly contacted Pena about consulting work. An Italian racing team wanted to know if the design could scale up. An American hot rod magazine wanted to feature the engine, but backed out after VW's advertising department made some phone calls. The corporate world had circled the wagons. Raphael Pena had committed the cardinal sin of being right when the establishment was wrong. He would pay for it. The technical legacy. Despite VW's best efforts to memory hold the futuresque engine, the technical innovations influenced Mexican and international performance culture in ways that are still visible today. First, the concept of direct-acting overhead cams on VW engines became a holy grail for serious builders. Before Pena, everyone accepted that pushrods were just part of the VW architecture. After Pena, multiple shops started developing their own OHC conversion heads. None achieved the sophistication of the futuresque design, but the idea was out there. The 4-valve per cylinder concept for air-cooled engines eventually made it into production. Porsche's 996 engine, introduced in the late 1990s, used 4-valve heads on an air-cooled flat 6. The cooling fin optimization principles that Pena pioneered showed up in various air-cooled performance applications. Nobody credited him, but the concept spread. The specific output numbers that Pena achieved, 129 horsepower per liter, naturally aspirated, wouldn't be matched by production car engines for another decade. Honda's VTEC engines in the early 1990s finally hit similar specific outputs. Pena had gotten there in 1982 with hand tools and aerospace engineering knowledge. The Mexican VW performance industry exploded in the mid-80s. Pena's success proved that Mexican engineers could compete with and exceed anything coming from Germany or the United States. A whole generation of young engineers and mechanics saw what was possible when you ignored conventional wisdom and started from first principles. Several Mexican engineering students used the futuresque design as their thesis projects, analyzing different aspects of its performance. UNAM's mechanical engineering department invited Pena to lecture in 1985. His talk, titled "Thermal Efficiency Optimization in Air-Cooled Engines," was standing room only. The design principles influenced other projects beyond VW engines. The cooling fin optimization techniques showed up in motorcycle engine designs. The combustion chamber geometry influenced some experimental aerospace applications. Knowledge doesn't respect corporate boundaries. Once an idea is out there, it spreads. Interestingly, some of Pena's innovations eventually appeared in production vehicles without acknowledgement. Audi's 5-valve per cylinder engines in the 90s used similar combustion chamber geometries. The individual throttle body setups that became popular in performance cars in the 2000s looked remarkably similar to Pena's 1979 design. Patents expire. Knowledge becomes public domain. The specific technical solutions that Pena pioneered became part of the general pool of engineering knowledge. His name might not appear in textbooks, but his ideas do. The legacy also lives in the small community of people who remember. There are probably 20 or 30 original Futuristic equipped Beetles still running in Mexico. The engines are treasured, maintained, occasionally exercised at underground races. They're artifacts from a time when one man with enough knowledge and determination could embarrass an entire industry. Modern VW enthusiasts occasionally try to recreate the Futuristic design using contemporary manufacturing techniques. With CNC machining and computer-aided design, the fabrication challenges that Pena overcame manually are much simpler. But even with modern tools, few have matched his achievement. The engineering knowledge required is still substantial. You can't CNC your way to genius. What happened to Raphael and his engine? Raphael Pena never got rich from the Futuristic engine. The legal and corporate pressure from VW effectively prevented any commercial production. Individual engines were built for enthusiasts who could afford them, maybe 50 total over the years. At approximately $10,000 per engine in 1980s money, they were expensive toys. Pena continued working as a consulting engineer through the 80s and 90s. He did work for various aerospace companies, industrial manufacturers, anyone who needed complex thermodynamic analysis. His VW engine work became a side passion, not his main career. In 1991, Pena designed a second-generation Futuristic engine, incorporating even more radical features: electronic fuel injection, variable valve timing using mechanical systems, computer-controlled ignition timing. This version supposedly made 240 horsepower from 1800 cc, but only 3 were ever built. The cost and complexity made them impractical. The original engines, the few that still exist, are scattered across Mexico and the southwestern United States. One is in a museum in Monterrey dedicated to Mexican automotive innovation. Another is owned by a collector in California who occasionally brings it to VW shows. A third is still in a running car owned by Pena's son, who occasionally drag races it for fun. VW never publicly acknowledged the Futuristic engine. Corporate histories of VW in Mexico skip over the entire episode. It's like it never happened, which is exactly what large corporations do when faced with embarrassing reminders that they don't have a monopoly on innovation. Pena himself retired in the early 2000s. He lives quietly in Mexico City, occasionally giving interviews to automotive journalists who discover his story. He doesn't seem bitter about the commercial failure of his design. He proved his point. The engineering worked. That was enough. In 2018, a Mexican engineering magazine named Pena one of the most important automotive engineers Mexico ever produced. The article detailed his work on the Futuristic engine, complete with technical drawings and dyno sheets. VW declined to comment. The Futuristic engine remains what it always was: a monument to individual genius, a middle finger to corporate complacency, and proof that sometimes one person with knowledge and determination can outperform an entire industry. Why this story matters. The story of Raphael Pena and his Futuristic engine matters for reasons that go way beyond Volkswagen or Mexico or air-cooled engines. First, it's a perfect example of how innovation happens outside the boundaries that corporations and established institutions create. VW had effectively infinite resources compared to Pena. They had hundreds of engineers. They had advanced testing facilities. They had decades of experience. And yet a single aerospace engineer working nights in a garage out-innovated them completely. This keeps happening throughout automotive history. The best ideas often come from the margins, from people who aren't constrained by corporate thinking or conventional wisdom. Pena didn't know what was impossible, according to VW, so he just engineered the best solution he could design. Ignorance of limitations is sometimes an advantage. Second, the story highlights how geography shapes technological development. Pena's innovations never achieved their commercial potential, partly because he was in Mexico, not Germany or the United States. If the Futuristic had been developed in California or Stuttgart, it might have revolutionized air-cooled engine design. Geography shouldn't determine whose genius gets recognized, but it does. Third, it demonstrates corporate behavior when faced with external innovation that threatens their narrative. VW's response wasn't to embrace Pena's work, or hire him properly, or acknowledge his achievement. It was to suppress, threaten, and ultimately ignore. This is standard operating procedure for large corporations. They'd rather preserve their own mythology than credit outside innovation. The lessons for modern engineers are clear. You don't need permission to innovate. You don't need corporate resources to develop revolutionary ideas. You need knowledge, determination, and the willingness to ignore people who tell you something is impossible. Pena had a calculator and access to a machine shop. That was enough. The story also raises questions about how many other brilliant innovations are sitting in garages worldwide, unknown because the engineer couldn't navigate the commercial and legal barriers to getting their ideas recognized. How many other futuristic engines exist in different industries, built by people without the connections or resources to commercialize their work? Finally, this story is a reminder that the underdog can win. Not always, not easily, but it's possible. Raphael Pena built an engine that outperformed anything VW produced. He did it with a fraction of their resources. He proved that expertise and determination can beat bureaucracy and money. The futuristic engine isn't just a mechanical achievement, it's a philosophical statement. Innovation doesn't belong to corporations or institutions. It belongs to whoever's smart enough and stubborn enough to pursue it. Sometimes that's a multinational corporation with billions in R&D funding. Sometimes it's one Mexican aerospace engineer with a borrowed machine shop and a refusal to accept that something's impossible. The next time someone tells you that you can't do something because you don't have enough resources or connections or credentials, remember Raphael Pena and his 200 horsepower Beetle engine that shouldn't have existed. And then, go prove them wrong.